Alright. Assalamualaikum and a very good morning to everyone.
Good morning, teacher.
Good morning. Okay, you can have a seat now. You can have a seat. So my name is Teacher Hariz. You can call me Sir Hariz. And today we are going to learn on functions. Okay. So you guys just came back from your big break, right?
Yes.
From your school break. Okay. So this is going to be our chapter 1, 4 from 5. Okay. So if you still remember, do you still remember relations?
Not really.
Not really. Okay. Let us have some review basically. Okay. Let's review back. What are relations? Relations are basically a set of ordered pairs. Okay. So what is a set? Tarvin.
A set.
Yes. What is a set?
A set that has the round thing, right?
Yes. Close enough.
And it has numbers, then we connect it using one straight line.
Okay. Lloyd. You
I
want to
try?
try? Yeah, sure. Go
A
ahead.
set is a collection or a group of something or things.
Okay. That's a very good answer. Thank you both, Tarvin and Lloyd. And that is basically correct. It is a collection or a group of, in the case of mathematics, it's a collection of numbers or values, right? So for a set, for relations, it's basically a collection of said sets, right? So let's put one set here, okay? Let's put 1, 3, 2, 4, 5, 6, okay? So this is what we call a relation. And a relation can have one-to-one. Okay, let's take a step back actually. With domain and range. Okay? Okay, and this is still relations, okay? So don't get me confused, this is relations. Okay. So let's try 1, 2, 3, 4, 5, and 6. Okay, so relations can have, oh yeah, start it.
Teacher, when I studied last time, that one on the left was domain and the right was codomain. Is it the same?
Domain, you mean this one is domain and this one is codomain?
codomain.
That is correct basically. It's just another name that we use
okay.
for these two.
Okay, teacher.
So this is domain. This is also called a codomain. Yes. You call this range, but it can also be flipped. But that is going to be in a later chapter, where there's going to be inverse functions. Okay. So relations can be one-to-one. So you have 1-to-1, for example. So this is a one-to-one relation, and then you also have one-to-many, which is okay, from 1 here, and then it goes maybe 5, and then we have here. Okay, basically 1 going to many. I mean 2 can also go to 6. Yeah, so that's 1 to many. Okay. Oh. And then we have many to 1. So basically we have 1 going to 4, 2 also going to 4, 3 also going to 4. This is many to 1. Many, sorry, 5. Wait, this is many to many actually. Basically many inputs going out to many outputs. So this is many to many. Lastly, let me re-visualize many to 1. So for many to 1, it's basically from this side, it goes many going to just one output. Like this one has many input just going into one output. So that's a relation. But what is it that makes a relation a function? So imagine yourself, Tarvin and Lloyd. Okay, Tarvin, imagine you have one ID, one IC basically, your IC card. And then imagine Lloyd have two IC. Okay? So, when you look at it, Lloyd might have a bit of a problem because he has two different IC, right? While you only have one. So you know that's your only IC. You know that's your only identification. So nobody will get confused about it. And for Lloyd, he will have a bit of a problem because the IC, he has two ICs now, right? So that is basically what functions are. It's a relation that will have one output, one input, and it gives out one output. It has to be exactly one for each. One input, one output. So in the case of Lloyd just now, he basically has two input, one input, which is himself, but he has two output, which is two IC. So that's the relation. That was what's going on basically. So for functions, functions are basically a special type of relations. And the only functions that can happen is a one-to-one and also one-to-many relation. Alright. So I have already shown you a simple mapping diagram. Let's look at how it looks like if we make it into basically another diagram. Let's make another diagram actually. So that you will know how it looks like. Let me look at my resource real quick. Okay. So we have here two different relations, right? Which one would you say is a function if you map it out like we did just now? Lloyd, can you help me out by drawing the domain and range, that just like we did just now?
I'm not sure.
Okay, it's okay, you can just try. So from here,
range. Hey, wait, is this the color domain and range?
no, this is this one. Each one of these are different. Yeah, this one is different. This one is A.
Okay.
This one is B. Okay. So draw your domain and range for A, and then Tarvin, you can draw for B. Okay. So what I drew just now was actually domain and range for a number for a set. Okay. Thank you, Lloyd. Tarvin, wait. You wanna try for B? Okay. Alright, good job, Lloyd. Good job.
Is it correct?
I will tell you. I will give you the answer after this. Okay. Oh, you won't put dots on it. Okay, good. You have learned of this during, I think, Form 4. So you should at least know how to do relations. domain and range. That's good, that's very good.
Thank you.
Thank you, Darwin. Alright, class. Let's look at A. Alright, 1 goes to B, 5 goes to A, and 8 goes to B. So this is correct. Is this a function? Remember, a function has to have one input, okay, basically one input. It goes to exactly one output. It goes to one output. So let's look at A first. One input, which is 1, goes to B. Okay, that's 1. And then we have one input, which is 5, going to A. That's also 1 to 1. And lastly, we have 8, which is one input, going to B. One output. So this is a function. What if suddenly 8 has another output? What if 8 suddenly goes to A? Then it becomes not a function anymore, because one input, which is 8, goes to 2 output. Remember, it has to be just one input going to exactly one output. So if we look at question A, it's basically a function, because 1 goes to 1, 1 goes to 1, and then 1 goes to 1. 1-to-1 relation. So this is a function. Okay? A function, again, drill it in your head. It is a one input going to exactly one output. It cannot be one input going to many output, and it cannot be many output going to many output. Many input going to many output. Okay? What about B? Let's look at the relations first. 1 goes to B, okay? 5 goes to A, and then 5 goes to C. So this one is one input going to two outputs. So this is not a function. A function has to be only one input, one output. So since 5 here is one input going to two outputs, it's not a function. Okay, so we can conclude that A is a function, B is not a function. Okay, so now at least we get that sorted out. Okay, remember how to draw the domain and codomain. It will be in your homework after this. Okay. All right. So now that we know how to draw domain and range and how to get inputs and outputs, let's talk graphs. Because when we talk about functions, usually there will be graphs involved. Especially later on in the later chapters, you will be learning how to solve functions and then sketch a graph. And so we will go to 3 different shapes of graphs that you will encounter later on during the chapters in the later half of the year. We have Y, X. Okay. Everybody still remember how to draw a graph, an axis, right? X has to be horizontal, Y has to be vertical. Okay. Y, X, and then let's put another one here. Y, minus X. Okay. So for the first one, let's put this as A. This one is B. This one is C. Okay, so for A, it's a straight line graph. For B, a parabola. And for C, a circle. Okay. So, I'm going to teach you a very neat trick for graphs. If you want to check if your graph is a function or not, and like from here we cannot know for sure if it's a function or not, you could do what's called a vertical line test. So everybody knows what vertical line is, right? It's basically going up and down. Okay, it's basically, that's vertical. So let's start with A first. Basically, just take any point in the graph and you just draw a line. Okay, a vertical line. Okay, jangan. Okay, I don't do horizontal line, vertical line. Okay. And then you look at the vertical line and you see if it intersects the line of the function. So in the case of this one, it intersects here. Does it intersect anywhere else? No, right? So that means it's a one-to-one, basically a one input to one output. So that means this is a function. You can even test it going somewhere else. Yeah, from here, yeah, that's also 1. You can even do it slightly in the middle. That's also 1. They only intersects once. So that's the vertical line test. So we know this is a function. Alright, Lloyd,
Yes.
do you want to do the vertical line test for me?
Sure.
Okay, you know how it is, right?
Yeah.
Just vertical line, and then it goes only one intersection. Only
Okay.
one intersects.
I'll try.
Alright. Yeah, try it, try it. Okay, Tarvin, are you good?
Yes.
Okay. Alright, so is that a function?
Yes. I think it is.
Class, do you think it's a function?
Yes.
Correct, it is indeed a function because
You intersect at one point.
exactly. We can even try it here if you want to. Just get this one. It also intersects once. Let's try on this side. It also intersects once. So this is a function. Alright, Tarvin.
Yes, teacher.
Let's try and see if C is a function or not
teacher.
by using the vertical line test. These graph shapes, you will encounter this later on in the future. But for now, we only will learn about how to check it if it's a function or not, just to hammer home what a function is.
Teacher, it does intersect at 2 points, so it is not a function, correct?
Indeed, it is. Okay, that's very good, Tarvi. He learned very fast. He learned very quick.
But, sorry teacher, one question about
Yes.
the circle. You said that if it intersect at 2 points,
Yeah.
it is not a function, right?
Yes, it is not a function.
But what if the vertical line test I would do like at the very edge, at the
Oh, you mean here?
at the boundary? Yes.
Ah,
It only
okay.
intersect at 1 point though.
Okay, that's
So-
actually a very good question. Because
Is
if
that
we
a
go to
function?
the edge of it,
Yeah.
if you go to the edge of the circle, you will only get one intersection,
True.
which is true. But remember what a function is. Remember what a relation is. A relation is a set of ordered pairs. That means it has to have a bunch of other pairs as well. Okay, again, let me just write it real quick. 1, 2, 3, 4, 5, 6. Alright. It has to have multiple ordered pairs. It has to have basically another pair. If you only have one, this is not a relation. No, this is not a relation because it is just one going. Not only is it just one output going, one input going to one output, but there's basically no relation. You have to remember again, relation. Have you guys been in a relationship?
No.
No, right? Okay, don't date. You're still in high school, but basically that's what a relation is. Yeah, that's what a relation is. It has to have another pair with it. So in order to make this into a relation, it has to have at least another pair. 1, 2, and then let's make 3, 5, for example. So it has to have another pair. So that's the same thing goes with this one. The same goes with this circle as well. Just 1 or 2 won't cut it. You need to have a bunch of ordered pairs. And then just by doing this vertical line test, if you just see one of the vertical line tests giving you 2 intersections, that means automatically it's not a function. And because a function needs to have an ordered pair, and each pair needs to have only one input going to exactly one output. You cannot have multiple outputs. Okay, I hope that answers your question.
Yeah.
Right? Okay, good question, good question. Because yes, if you do that on a circle, you can get at least 2, right? You can at least get 2, one intersection. But that is not a proper function yet. You need to have multiple ordered pairs in order for it to be a function. Okay.
Sorry, teacher, question again.
Yes. Go ahead.
I've also heard about the horizontal test horizontal line test. So is that also checking about functions or?
Horizontal line test is for another topic that you will also learn in the future. I won't spoil the surprise. You'll learn about it in the future.
Alright.
Alright, so now that we have known how to draw the domain and the range and how it looks like in graph form, now let's look at how to write it in notation form. Okay, so we start first with fx equals to, let's say, 2x plus 3. So this is how you write the notation for function. F is the function name. Function name can be anything. It could be F. Usually it will be F, but sometimes you will see it be G. Sometimes you'll see it be, you can even be Z actually. It can be Z. It can be anything because it's a name. Macam you guys, you have Lloyd, you have Tarvin, it's your name. It can be any name. You could put if you want Lloyd X, but it is too long, and it will be quite weird for you to write it that way. But you could do it. Okay, don't get me wrong, you could do it because it's just a name. Remember, it's just a name. So because later on you will encounter a lot more functions, and you don't really want to draw it. You don't really want to write it as f1 x, f2 x. It becomes repetitive. It becomes confusing, right? So you instead of doing this, you could just make it so that, okay, we have fx, we have gx, we have let's say, what is your favorite letter, Tabe?
T.
T, yeah, we can do tx. Yeah, so you can do any name in front.
Who will me?
It's okay, lah. Yeah, I already put your name as the example.
Yeah, I wanna ask, can I use X as well?
Yeah, you could.
But
It will
like,
be confusing.
Yeah.
I will say that it will be confusing, but you could. You could x. It will be very confusing. Again, usually we will stick with F, G,
Okay.
and there's another one, H. Usually we will stick with these three,
Right.
F, G, H. But again, if you see a function in this shape, don't be alarmed. It's basically fx. It's basically the name of the function. Okay.
Okay.
So what about the x here? This is your input. So your input can be any number, as long as when you plug it into the right side, you'll get an output. So this is an input. X can be any whole number or any rational number. Okay? So X could be 1, could be 5, 6, 10, 100. And then lastly, we have on the right side, the whole thing on the right side. This is what you call the output. So basically the whole fx, like f itself is the name, x is the input, fx itself, like this whole thing, which is the one here, is basically the output. Okay? To remember it easily, you just have to remember that this, basically the whole right side is the output. So how do you get the output? Okay, that's the question that we will tackle today. When you are given a function, whatever value of x that you put in here, you substitute this into this one. So if, for example, we will take this example, okay? Fx equals to 2x plus 3. For example, they give you x equals to 2. Okay, so Lloyd, where do you put this 2 on the right side?
Beside the 2, I substitute with the X.
Yeah, exactly. So whatever x you see here, whatever basically the same letter, this is x, right? The same letter, you substitute 2 plus 3, and then you'll get 7. So this right here, this is the output. Okay? You can experiment with it. You can substitute this with 3, 5, and then it will give you one output. And that's basically how you write a function in notation form. Okay? It can be any whole number, and it can be any actually in the later chapters, you will be also in real numbers as well. Okay, so I'm gonna ask a recap question now. So what is a function, Lloyd?
Function is if you have like in my own word, if you like have if you do the vertical line test,
Okay.
it only intersects at only one point.
Okay, that is for the graph. What is it in general?
Or if you only have one input goes to one output.
Yes. Also add in the front a relation
Oh,
that
okay.
only has one input and it goes to one output. That is correct. Just add relation at the front. A relation that has one input going to one output.
Okay.
Okay. So can one input have two outputs? Like one input having two outputs. Tarvin, can a function have that? One input, two output.
No.
Okay, that's correct. When a one input has two output, it immediately becomes a non-function. It's not a function. Okay. And how this is actually Lloyd just answered this. How do graphs help us identify functions? Lloyd?
Yeah, by using the vertical line test.
Exactly. Just use vertical line test on any graph that you see. If it intersects twice or more, that's immediately not a function.
Okay.
Okay. So basically, all this thing is basically to teach you guys that a function assigns exactly one output to one input, and you can represent it using graphs and also using notation. It will give you exactly one input, for in this case 2, giving you one output, which is 7. In later chapters, you will see one input giving you multiple outputs, which is plus, minus, or maybe 7 and 2/3. But that will be for the next chapters, okay? So right now, we just want you to understand this one properly, to understand functions and notations.
So
Alright. And, oh yeah, do you have a question? Lloyd?
yeah, but just now when you said that having one input and then multiple outputs, so that's not a function, no?
Oh no, it's not. This is still a function notation.
Yeah.
It is not going to be a proper function, but that is going to be, again, we are going to learn about it later on in the future. Actually, on the homework that I'm going to give you after this,
Yeah.
there will be a question where there will be basically 2 different outputs.
Okay.
Okay, and I want to see how you guys solve it. Okay, you can ask your friends, you can ask your family members maybe, but overall, that's what you have to remember. A function will give you one input going to one output. Okay?
Okay.
So I'm gonna give you a homework after this. It's just 3 questions. 2 of them are basic questions, and 1 of them is a HOTS question, and then submit it next week. Alright?
Alright.
Teacher.
Alright, thank you everybody.
Thank you, teacher.
Alright, thank you. I'll go out of the class now.